and this is section 4.4, and so we're going to do something really nice here. We're going to develop a quadratic formula, and so we can use this for any quadratic equation. If you can write it in the form ax squared plus bx plus c, you can solve it very quickly using this formula, okay? And so sometimes people will factor, you know, because it's easy, or they'll do complete the square or whatever, but you know what, if you ever get frustrated, you can't find your solutions, works every time, okay? So copy the calculations, describe the steps in the following example. Okay, so I'm going to do this one just like we've done all the other ones. Okay, the first thing we did when we had an equation like this is we moved our constant. Term, okay, over to the right. Okay, so we had 2x squared plus 7x, and then we made our negative 1 over here, so subtract 1 from both sides. We end up with the negative 1 there. Okay, so that was the first thing that I did. I'm going to try to make this small because I'm going to do something over on the right in a minute. Okay, so that's my first step. Okay, the next thing I did, because I wanted to not have that coefficient on the x squared, okay, so I divided everything by the coefficient of the x squared term. Okay, so I went like that, and I get x squared plus 7 over 2x equals negative 1/2. Okay, so this should be totally familiar to you from the last section. Okay, my third step, I would take 1/2 times the coefficient of the x term and square it to get the third term. Okay, so 7 over 2, half of that, okay, 1/2 times 7 over 2 is 7 over 4. Okay, and when I square 7 over 4, I get 7 squared over 4 squared. Okay, and so of course, I'm going to add the same thing over here. Okay, sorry, it's getting squishy. Okay, but hopefully you've got this good enough to follow. Okay, and then I'm going to rewrite the left side as the binomial squared. Okay. So I make that x plus 7 over 4 squared. Okay, and I simplify the right as I'm doing that. So this is negative 1/2, which is the same as negative 8/16. So that becomes 41 over 16. Okay, and then next step is take plus or minus the square root of both sides. Sorry, that looks funny, but I'm trying to make this work. Okay, take plus or minus the square root of both sides. So I get x plus 7 over 4 equals plus or minus root 41 over 16. Okay. And finally, I will subtract 7 over 4 from both sides. So negative 7 over 4, okay, plus or minus root 41 over 4, okay, and then you can just rewrite it. Okay, so that's my solution. X equals negative 7 plus or minus root 41 all over 4. Okay, so I'd say for this step, subtract that constant on the left side, or add or subtract, I guess, from both sides. Okay. All right, and that's just exactly what we've been doing as we complete the square. So I'm just showing it to you because that's going to be something that I'm going to do in a more general way now. Okay, so I'm going to start over here, and I'm going to use my general form of my quadratic equation. So ax squared plus bx plus c equals 0. Okay, so step 1, tells me move the constant term. Okay, my constant term is c, right? It's the one without the x in it. So ax squared plus bx equals negative c. Okay? Divide everything by the coefficient of x squared. So I'm going to end up with x squared plus b over a times x equals negative c over a. Okay, I've divided everything by a. It canceled out in the first term, and then I have a denominator of a for everything else. Okay, that was step 2. Step 3, take 1/2 the coefficient of x and square it. Okay, so that's going to give me the third term. So 1/2 times b over a is b over 2a. Okay, so when I square that, I will just write it as, well, I'll square the b squared, and I'll square the 2a. That becomes 4a squared. Okay, and then I'm going to have to add the same thing over here. So negative c over a plus b squared over 4a squared. Okay, so that was step 3. Now I rewrite the left side as a binomial squared, and so remember that's just going to be x plus b over 2a, right, because it's half that second coefficient, squared, right? And we can definitely simplify the right side by doing a common denominator. Okay, we would have had to multiply the top and bottom of this one by 4a, right, to make a common denominator, and that would have given us, that would become negative 4ac over 4a squared, so negative 4ac plus b squared over 4a squared. Okay. Holy, this is getting super ugly. I should be doing it in a better way. Okay, so I'll just take the square root of both sides. Okay, so this becomes x plus b over 2a. Okay, that's step 5. Take this plus or minus the square root of both sides. So this square goes away. This becomes plus or minus the square root of, I'll put the b squared term first, so b squared minus 4ac on top over 4a squared. Okay. The next step is to subtract the constant from both sides. And when I do that, actually before I do that, I'm going to add it as a negative because I like to have the rational part before the part that's under the radical sign. So this can become negative b over 2a. Okay. And that's going to be plus or minus. And then I'm just going to keep this top part under the radical sign, so b squared minus 4ac. Okay. And then on the bottom, I don't need to have that under the radical because 4a squared is a perfect square. Okay, so it's over 2a. Okay. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Okay. For any quadratic equation written in the form x squared equals, ax squared plus bx plus c equals 0. Okay. You can substitute those numbers in, and you can find out what your roots are going to be. Okay. It will work every time. All right. So that's my quadratic formula. It's very important, and I hope that you will memorize it. Okay, so I'll write it again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and yeah, you should memorize that. Okay. So yeah, so let's just take a look quickly at that part under the radical sign. Okay, that's called the discriminant. Okay. And so the nature of that is going to tell us what kind of roots we have. Now, you can probably imagine that if that equaled 0, then you would end up with some number, negative b plus or minus 0. Okay. Now, when you plus or minus 0, you're not going to get two different answers, right? You get one. Okay. So if that discriminant, so you don't have a radical anymore because that was 0. Okay, and you don't have to worry about the plus or minus giving you two answers. If that discriminant is equal to 0, then you're just getting one root, negative b over 2a, right? So That's nice because if the discriminant equals 0, okay, you have one real root. Okay. Now, if it equals a perfect square, that's nice because you get rid of your square root. Right? So you're just going to have rational numbers, but you will have two of them, right? Because you have to add and subtract that to get your two roots. Okay, so if b squared minus 4ac equals a perfect square, then we will have two real roots. Okay, two different, distinct, or unequal real roots. Okay, now if you are not fortunate enough to have a perfect square, when you do that, okay, then you're going to have a radical. Okay, and you'll have two different roots, and they're both going to be real, and the other really important part, because yes, they're real, but they're also rational, meaning no radicals. Okay, two real rational roots. Okay, if b squared minus 4ac is just not a perfect square. Okay, as long as it's still positive. Okay, then you have two real irrational roots. Okay, because that square root sign is not going to go away because you can't take the square root of the number under it. And if you happen to have a negative number under there, okay, you end up with a negative number. You actually end up with no real roots, okay? So there's not actually going to be a solution to this until you learn to deal with square roots of negative numbers, which I don't think is going to happen today. No. So no real roots, and no, that means no x-intercepts. Okay, so another nice way to tell how many solutions you're going to have, okay, and what they're going to be like. Okay, so b squared minus 4ac equals 0. You have one real root. That just means it's just going to touch the x-axis. Okay, if it's a perfect square, you're going to have two real rational roots, so it's going to cross the x-axis at a nice rational number. It might still be a fraction, right? If you have not a perfect square but still a positive number, you'll have two real irrational roots, meaning there's going to be some kind of a square root or something, yeah, a square root involved. And then if it's a negative number, you won't have any real roots. Okay, so that's just shown in the summary as well. Okay, look at that. So it's greater than 0. There are two distinct real roots. It doesn't say anything about there being rational or irrational. That was just something extra I threw in, I guess. Okay, if it's equal to 0, the discriminant, you have 1, and if it's less than 0, you don't have any. Okay.